Hey guys, so this is the second half of the L'Hopital's rule lesson. It's short. We're gonna do a couple harder problems just for practice. Please have already done the other homework though, because I want you to practice before seeing the harder ones. Alright, so pause and try the do now. Don't go too crazy with it, it's not that hard. Alright, so for this one, you really need to recognize that that's a definition of the derivative, right? That's f of x, oopsies. That is f of x plus h minus f of x. Wow, it helps if I put plus h all over h. So in this case, our x is 4, right? And what's our function? So our function is f of x is ln of x at the point x equals 4. So what's the derivative? It's the definition of the derivative. So the derivative is 1 over x. And then just plug in your 4. 1/4. B. Done. Okay. So we've talked about the two main indeterminate forms, but there's a few others. So 0 over 0, infinity over infinity, but sometimes we see others. 0 times infinity, infinity minus infinity, 0 to the 0. Are you erasing? 1 to the infinity, and infinity to the 0. Now some of these you would think like 1 to the infinity, why isn't that just 1? And it's the mathematicians, they figured this out, not me, so don't yell at me. This is just reality of what it is. Okay, so I want you to pause and see if you can figure these out. So if I try to plug in infinity, right, ln of infinity is infinity, so we get infinity over infinity, which tells us we can use L'Hopital's rule. So the limit as x approaches infinity. All right, what is the derivative of the top? So ln, so that's 1 over ln of x times the derivative of the inside, all over 1 over x. Now the 1 over x is just cancel. So this is the limit as x approaches infinity of 1 over ln of x. So we just get 0. All right, number 2 is a little tricky. Took me a minute. All right, so if we try to plug in 1, we get infinity over infinity. So this is an indeterminate form. So I'm going to use L'Hopital's rule. Limit x approaches 1 from the left. Negative 1 over 1 minus x, right? Derivative of the inside is negative 1. Derivative of cotangent is negative cosecant squared. And then derivative of the inside is pi. So now here's the hard part. We need to rewrite this. So this is negative 1 over 1 minus x all over negative pi over sine squared of pi x. Okay, so what happens here, the negatives, so when we simplify this, this becomes the limit as x approaches 1 from the left of sine squared of pi x all over pi times 1 minus x. So I multiplied by the reciprocal, right? The sine squared and all the things, right? Pi x. So we get that. So now when I try to plug in 1, I get 0 over 0 again. So we're going to do L'Hopital's rule again. So then that's the limit as x approaches 1 from the left. The derivative of the top, 2 sine of pi x, cosine pi x, derivative of the inside is pi, all over pi times negative 1. So now when I plug in, sine of pi is 0 over, all that's multiplying, negative pi. So I just get 0. Right, so that one's pretty rough. All right, pause, and I want you to try these on your own. So I get 1 over 0, 1 over 0. Remember, you can't use L'Hopital's rule unless it's a fraction. So we have to turn this into a fraction. All right, so this is going to be the limit as x approaches 0. Our denominator is going to be x, e to the x minus 1. My numerator becomes e to the x minus 1 minus x. So if we plug in 0, we get 0 over 0. All right, so this does work. So we're going to do L'Hopital's rule. Limit as x approaches 0, e to the x minus 1 all over e to the x minus 1 plus x e to the x minus 1. Derivative of the first. Oh, there's no plus 1 in there. Plus 1 goes away. All right, so now let's see if we plug in 0, we get 0 over 0 again. So let's do it one more time. Limit x approaches 0. This should be the last time. E to the x over e to the x plus e to the x plus x e to the x. All right, now we can plug in e to the x. E to the 0 is 1. So we have 1, 1, and 0. So the answer is 1/2. That's not that terrible. All right, again, we get 0 times infinity. So we need to rewrite this. So what's the easiest way to write this as a fraction? So this one's a little tricky, but we can do it. All right, I'm going to be truthful. I did this whole problem out and it was wrong, so I had to delete it and try again. So when you're using L'Hopital's rule, like I said before, it has to be a fraction. So what I tried to do was move ln of sine x to the denominator, but that did not work. So I need a fraction. So I'm going to try it again. And I'm telling you this just so you know, like, sometimes you have to just try different things. So I'm going to turn that sine into cosecant so we can go on the bottom. So now I have that infinity over infinity. So now I know that I can use L'Hopital's rule. So we have the limit as x approaches 0 from the right. ln of sine is 1 over sine times cosine. All over derivative of cosecant is negative cosecant x cotan x. All right, so now I'm pretty sure I can simplify because this is cosecant, right? Those cancel. So we have the limit as x approaches 0, cosine x over negative cotan x. That's cosine times tan, which is cosine times sine over cosine. So this is the limit as x approaches 0 from the right of negative sine x, which is just 0. So these are hard. I'm not gonna lie, these are hard. These get really difficult really quickly. We're not gonna go too crazy with these, I promise, but it's definitely something that you need to learn. Okay, so that was the last one. I want you to go do the practice AP problems, and then you also have this homework assignment.